How are you, my friends? This is Calculus 1 solved questions. The questions here are about horizontal and vertical tangent lines. Let's see question number 1. Write an equation of the tangent line to the graph of this function, 6 cube root of x squared minus 4 divided by square root of x at x equals 1. This is so nice to find the derivative. See, here we write the function y, the f of x is y always, 6x to the power 2 over 3 rational exponents minus 4x to the power minus half. Why do we write it like this? So that we can find the derivative easily. So this will be the derivative dy over dx, or f prime or y prime. It will be 6 times, bring the power here, 2 over 3, x to the power 2 over 3 minus 1. Same thing here, minus 4 is in the question. The power here minus half will come down, x to the power minus half minus 1. So this 6 times 2, 12 over 3 is 4, divided by cube root of x, because 2 over 3 minus 3 over 3 becomes minus 1 over 3. Minus half minus 1 becomes minus 3 over 2. So it will be here minus with the minus plus 4 over 2. 2 divided by square root of x cubed. Now be careful here. The slope of the tangent line will be the derivative, see, f prime or dy over dx, when x equals to 1. 1 is given there. See, 1 is given in the question here. So I put 1 there in the derivative. 4 over 1 plus 2 over 1, it will be 6. That's the slope. Now x is equal to 1. I can find y. Replace 1 in the function itself, in this blue one here. 6 cube root of x squared minus 4 over square root of x. It will be 6 minus 4, 2. So the point of tangency is 1 and 2. This is the equation of the tangent line. Y minus y1 is equal m times x minus x1. Put the numbers there. We have the slope m here, and we have the point 1 and 2. So y equals 6x minus 4. This is really important, very important question. Find all points on the graph of this function, f of x, x times square root of 1 minus x squared, x between minus 1 and 1, where the tangent line is either horizontal or vertical. At some points here between minus 1 and 1, at some points we have horizontal tangent like this. At some points we have vertical tangent. So we have to find these points. Just to review here with you, vertical and horizontal tangent lines. The easy is the horizontal tangent occurs when the derivative is equal to 0. But the vertical tangent, when the limit from the right or left of f prime is plus infinity or minus infinity, then we have a vertical tangent. Remember, the limit of the derivative will be plus infinity or minus infinity. Now, if we look at the solution of question number 2, we see that we have to use the product rule for the derivative because the function is a product of two functions here. So f prime will be the derivative of the first, derivative of the x will be 1, times the same function, 1 minus x squared to the power half, plus the derivative of the second one, v prime, it will be half 1 minus x squared to the power minus half, because it was half minus 1 becomes minus half, times the derivative of the inside function, minus 2x, times the u, here u, which is the first function here, u is x. Here we see 1 minus x squared, the same base, 1 power is half, 1 power is minus half. We can take a common factor with the smallest power, which is minus half. So what do we write here inside? 1 minus x squared to the power 1. From where we get this one? Half minus the power outside. Remember, half minus half. So it becomes half plus half, 1 here. And 2 will be cancelled. Minus x times x will be minus x squared. Simplify inside the brackets. You get 1 minus 2x squared divided by square root here 1 minus x squared. Because this is minus half, it becomes square root in the denominator. Now, every horizontal tangent, it will occur at f prime is equal to 0. So we can take the derivative, this one, 1 minus 2x squared over this is equal to 0. Cross multiply, you get 1 minus 2x squared is equal to 0. So x squared will be half. X will be plus or minus 1 over square root of 2. At each x here, we have a horizontal tangent. Let's find the y value. So x will be 1 over square root of 2. I have to replace this x in the function here, you see? So I put this x, 1 over square root of 2, square root of 1 minus 1 over square root of 2 squared under the radical here. So this will be 1 over square root of 2. 1 over square root of 2 squared will be half. 1 minus half is half. So when you multiply, you get half also. So this is the x value. This is the y value. See, that's the first point here. At this point, we have horizontal tangent. Same thing for the second x, f of minus 1 over square root of 2. It will be minus 1 over square root of 2. Here, when you square it, the minus will disappear. So we will have also half under the radical. So it will be minus half. So we have another point, minus 1 over square root of 2 minus half. This will be where the horizontal tangent. So we have 2 points there, 2 horizontal tangents. Now let's continue here. This is the derivative, as we have seen, 1 minus 2x squared divided by square root of 1 minus x squared. The vertical tangent occurs when we have f prime is undefined. See horizontal here? This is horizontal. This is horizontal tangent. We have found these points on the previous slide. So the denominator will be 0 here when f prime is undefined. So I take square root of 1 minus x squared is equal to 0. Square both sides, you get x equals plus or minus 1. Now take plus or minus 1. You can take x equals 1. You can take x equals minus 1. Replace it in the function here to get the y. So f of plus or minus 1 will be 0. So the graph has vertical tangent at 1, 0, minus 1, 0. Here, you see this is a vertical here. Vertical tangent, there's a vertical tangent there. So 2 points where we have vertical tangents, 2 points where we have horizontal tangent. That's why this question is very important. You can study it. Question number 3 is little nice because we have sines and cosines. Find all the points on the graph where this function, the tangent line is horizontal. 1 over 3 sine squared of x plus 2 cosine squared of x. X between 7 pi over 4 closed and 2 pi. Now for the solution of question number 3, we look at the function. It looks like 1 over u. All this is u. So we remember the reciprocal rule. The derivative of 1 over u becomes minus u prime over u squared. Remember that from lecture number 7. So there is a minus in the formula. And all this is prime. So we have to find the derivative of all this u divided by all this squared. So let's leave the minus. Inside now we have 3, so we leave the 3. Sine squared of x, the derivative will be, bring the 2 down, 2 sine of x to the power 2 minus 1, which is 1, times the derivative of the inside. The derivative of the sine of x is cosine of x, plus, same thing here, 2 times, bring the 2 down, 2 times 2, cosine of the x, 2 minus 1 becomes cosine of the x, times the derivative of the cosine of x is minus sine of x. Now go inside here, 6 sine of x cosine of x minus 4 cosine of x sine of x. You can add and subtract. So it will be 2 sine of x cosine of x, and there is a minus outside. So it will be minus 2. Now I can take this one here, this part, 2 sine of x cosine of x as sine 2x. Just to remember the formula here, sine of 2 theta, 2 sine theta cosine theta. This is lecture number 23 in the pre-calculus course. The horizontal tangent occurs when the f prime is equal to 0. So I can put here minus sine of 2x is equal to 0, multiply with the minus, sine of 2x is equal to 0. That means 2x is equal to, so what is the angle here? In the given condition, this is the given condition. x between 7 pi over 4 to 2 pi closed. Which angle in this interval the sine is 0? 2 pi. So 2x is equal to 2 pi divided by 2x will be pi. Let's find f of pi. 1 over 3 sine squared of pi plus 2 cosine squared of pi. Sine of the pi is 0. Cosine of the pi is minus 1. Square it. So all becomes half. So the function has a horizontal tangent at this point, pi comma half. This is x and y. Find all the points on the graph of this not easy graph. Cube root of x times x squared minus 3x plus 2, where the tangent line is vertical. Now for the solution of question number 4, we can write the function as x to the power 1/3 times x squared minus 3x plus 2. We have to use the product rule, u prime v plus v prime u. So let's find the derivative of x to the power 1/3. It will be 1 over 3 x to the power 1 over 3 minus 1, which is minus 2 over 3, times the second one here, leave it, plus the derivative of this 2x minus 3 times x to the power 1/3, leave it. Now this one you can bring it down, so it will be x squared minus 3x plus 2 divided by 3 times x to the power 2 over 3. And this one also 2x minus 3 times x to the power 1/3. So if you need to add these two, you have to make the same denominator, which is 3x to the power 2 over 3. Not easy. So I put here multiply up and down for this second term, multiply up and down by 3x to the power 2 over 3. So this will be in the denominator, and this will be the same x base. We can add the power 1 over 3, 2 over 3 becomes x, and there is a 3 there, and this is in the denominator with both. So now we can add easily x squared minus 3x plus 2. Here we multiply 3x, 2x becomes 6x squared, and there is x squared becomes 7x squared, minus 3 times 3x minus 9x, and there is minus 3 becomes minus 12x, and plus 2 over 3 cube root of x squared. This is the derivative now. See, the whole idea in the question is the derivative. Now we need vertical tangent occurs at f prime is undefined. So we take all this, the denominator, put it equal to 0. So the denominator is equal to 0. This is f prime from last slide. And this one, the function f. So here we can divide by 3. It will be 0 on the right side. Cube root of both sides, x squared is equal to 0. So x will be 0 only. Now take this x equals 0, put it in the function. Cube root of 0, 0 squared minus 3 times 0 plus 2, it will be also 0. So the graph has a vertical tangent at the origin because x is equal to 0, and here y equals to 0. For more questions on vertical and horizontal tangents, you can see lecture number 9. Or for more questions on Calculus 1, you can see the Calculus 1 solved questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you with another video, another topic. Thank you guys for listening.